It is time to begin lesson 3.2. Now, 3.2 is going to take all four math functions, adding, subtracting, multiplying, and dividing, and putting it in with decimals. So it's a lot of quick review that the book does. So we're going to slow down and take some detailed notes in a packet because there's not enough room in your book and there's a whole lot of print in there to where you can't show the steps. But I also have some specific notes that I want you to take. Once again, this is one of those things that sixth graders come to me that many of you have these gaps because you just didn't get it in fourth and fifth grade. And I'm going to give you a systematic way of learning this by asking questions. Then, once we get through this lesson and then the next day we do the assignment, I'm going to have this video available to you on Canvas. After that, then we're going to have some supplemental lessons because the book just jumps right into dividing fractions without reviewing how we add, subtract, or multiply fractions. Common denominators, not common denominators, cross-reducing. There's a lot of things to do with fractions that we need to review. So we'll have some things out of the math book once we get through this lesson. But I'm having this video, it's going to go a little faster, even though it's still going to be a long video, because I want you to be able to then go back through it after I teach you all the things in. So when we look at our I can statement for lesson 3.2, then it's I can solve problems by using the standard algorithm. And once again, like we said in the last lesson, don't let that confuse you. It's just a proven math process. So I'm going to be able to solve these proven math processes using the four functions of math: adding, subtracting, multiplying, and dividing, and decimals. So we should be okay as long as we can go through the steps that I'm going to teach you. The book is going to teach it a little different. I'm going to give you questions to ask. This is the way that I teach decimals, and I have taught decimals for many years. It's also the same way, the same pattern that we're going to use when it comes to fractions. Please take the notes that I'm at. All right, so our first question on our packet, once again, these are from the book, but I'm removing all the words and I'm giving you extra space. That's why it's in a packet. Please take your notes. And when I start doing decimal work, I'll ask the same question when I start doing fraction work, is can I do this? Can I add decimals? That answer is a yes. I am able to add decimals. Therefore, I need to be filling in these lines so I know what my steps are and I can reference this. This should then go in my math folder so I can always go back to it anytime I have a question. So then I'm going to line what? I'm going to line up my decimals. Now I'm going to suggest that when you're setting up addition and subtraction that you just simply put the first number on top. It doesn't matter that it has fewer decimal positions. So I'm going to line up my decimals, and then I'm going to show that I have an addition problem. My second step says to bring, and we're going to finish that statement by bring down the decimal, bring it straight down. I don't want to go diagonal. I don't want to have it in a weird, wonky place. I want to know exactly where it goes. Every year I have at least one sixth grader says, hey, I like to do my decimal after I do my math, okay, Mr. B? And I'm not going to force you to do it my way, but I'm telling you that many sixth graders that say, I'd like to do my decimal last, forget to put their decimal in their answer. And then their answer is completely wrong. To where if I have everything lined up nice and neat, I bring my decimal down. Then when I do my third and fourth step, I know where everything goes and I don't have to forget it at the end. So my third step, since everything is lined up, I brought my decimal straight down. Now I'm going to fill in with zeros. Notice I've added in the notes if needed. Sometimes you'll need to add 1 0, 2 zeros, 3 zeros, and sometimes you won't have to add any zeros. But any place that there's an open space, I need to fill in with zeros. Since there are 3 decimal positions in the bottom number, I need to have 3 decimal positions in the top number. My fourth step is simply, I'm now going to add. So I start to the far right, and I add 0 plus 4, which is 4. And then I add 6 plus 8, which is 14. I put down my 4, carry my addition of 1. Some of you skip that step of showing your addition of 1, and you forget to do that, so you put down a 4 as your next answer, and that's not it. So if you put your addition of 1, then you remember you're adding 3 plus 1 plus 1, and that's actually 5. 5 plus 1 is 6. 4 plus 2 is 6. What do I do next? Nothing. That's your answer. You're done. Your answer is 66 and 544 thousandths. So we have 4 steps we follow when it comes to adding decimals. But what about subtracting decimals? Right? You made adding decimals real easy, Mr. B, but now we're subtracting and I'm not really good at subtracting. It's okay. Follow the same steps and you will be fine, I promise. Our 4 steps start with the same question. Can I subtract decimals? And that answer is yes. So we're going to go through the same 4 steps. We're going to then line up our decimals once again. Put the first number on top. It is required in subtraction. Addition, you can switch them around and still get to the right answer if you do your math correctly. But subtraction, you must have the first number on top. That's why I suggest that it doesn't matter if it's addition or subtraction. You just put the first number on top, you know it's set up. So I'm going to line up my decimals. Then my second step in subtraction is I'm going to bring it straight down. I'm going to drop my decimal point straight down and have it there. That way, when I do start doing my math, I know it's in the correct position. My third step looks exactly the same as the last one with addition. I'm going to fill in with zeros if it's needed. And this one, once again, I need one. Now on 4, I'm simply going to subtract. Here's where some of you make a mistake. You say, well, I can't take 6 from 0 in your head, so you just take 0 from 6 and you flip it and you get 6. That's not it, my friends. And there are some of you that you do this every time. So I'm showing you, and I will mention it in class when I'm teaching it, that you have what we call phalanges. They're your fingers. Use them. At 52 with a math degree, I still use my fingers when I'm doing math. And like you'll hear me tapping on my desk when I'm doing my answer keys, when I'm figuring out my math problems. There's nothing wrong with using your fingers, and there's nothing to be embarrassed of. But if I put 0 fingers up on a hand, then I know I can't take 6 from it. So the top number is always how many fingers you put up on your hand. The bottom number is what you're taking away. And since I put 0 fingers up and I cannot take 6 possibly away from it, then I know I need to borrow from the 4. I would strongly suggest that you show these steps. That way you don't forget what's going on. I always get 6th graders to say, yeah, I'm really good at math, so I'm not going to show all of the steps because I'll remember it. Then they don't. So if I borrow from the 4 and becomes a 3, I carry that grouping of 10 over. I put the 1 in front of the 0. Now I have 10 minus 6. If I put up 10 fingers, yes, I can take 6 away and have 4 left over. So then I put 3 fingers up and I ask, if I take 8 away, oh, wait a minute, I can't take 8 away. So I have to borrow again. And now my 9 becomes an 8. I'm carrying a grouping of 10, or I'm just carrying a 1 and adding it in front of the 3. So now I have 13. And 13 minus 8 is going to give me 5. If I put up 8 fingers and take 3 away, then 8 minus 3, well, that's a 5 also. And then 2 fingers minus 5, can't do it, got to borrow. So from my 3, it becomes a 2. I put a 1 in front of my 2, and now I have 12. 12 minus 5 is going to give me 7. 2 minus 1 is the remainder of 1. So the same 4 steps in adding as well as subtracting decimals. So my final answer is 17 and 554 thousandths. All right, we got it? How about you try? Pause the video, come back and check your work once you've gone through your 4 steps. So hopefully you have your answer, right? And you've done as I've asked. So hopefully you asked yourself, can I subtract decimals? Yes. I need to line them up according to their decimals. And I see that I have 356.18 on top because that's my first one. I line up my second one, and then I know I need to bring my decimal down. And I'm going to fill in with zeros because that's the third step. And then, oh yeah, now I subtract. And I have 0 and I can't take 7 from it, so then I'm going to borrow. And hopefully you got, well, borrowing from 8 is a 7, and I carry over my 0 and or my 1, and 1 and 0 makes 10, so 10 minus 7 is 3, and 7 minus 5 is 2, and 1 minus 2 is impossible to do. So then you thought, gotta borrow again. So my 6 becomes a 5, I carry over that 1, and a 1 and 1 make 11. So 11 minus 2 is 9. And 5 minus 2 is 3. And 5 minus 4 is 1. And 3 minus 1 is 2. Oh, I'm done. Did you get it? And if you didn't, do you see why or where you might have messed up? And if you did mess up, is it because you didn't show all of the steps and indicate the math that you were doing? Right? Once again, this is not, I'm going to write the math problem on the paper, type it into my calculator, and then just put the answer down, and Mr. Barker is going to count it. No, that's not the way it works. I need to see your math, my friends. I need to know you can do this without a calculator, because come the spring when you take your standardized test, you don't get to use a calculator on the first part of the test. You have to be able to work it out on your paper. All right, so now that we have that answer, now we go to this next question, and notice it's different. We didn't say anything about whole numbers. We've always had 2 decimals. So this is where you just need to breathe and relax, because this is not difficult at all. We're going to still follow the same standard algorithm. We're going to follow the same proven math process. We're going to ask ourselves, can I subtract when I have at least 1 decimal? And that answer is still yes. So I need to, for step 1, line up my decimals. And then you're like, but there isn't a decimal on the 25. It's okay. But please listen to me, right? This is where some of us are really struggling, right? Everyone in here hears me just fine. No one needs a hearing aid other than your teacher, right? But the hearing is not usually the problem. It's the thinking. Listening involves hearing and thinking. Please listen to me. Think about what I'm saying. We talked about this last week. We talked about it the week before. When I have a whole number and I need to make it a decimal, I simply put the decimal at the end to the right of the whole number. So now I have 25 point, right? 25 and. Then I can line up my decimals. Because what I saw on the past couple of weeks lessons, you just made it a 25, you lined it up all the way over to the right, and you would have put it underneath the 69 because it was a much smaller number. And wow, we got some wrong answers. So we have to stop and think logically, and you know how to do it because I taught you and you just listened. I know you did. So we have 25 point. That means I need to bring my decimal down because they're lined up. And then I need to fill in with zeros. So we have 3 zeros to fill in with. Now I'm going to borrow through. Now, some of you asked me, how I was getting the answers I did when I borrowed through on a previous video. So I'm going to go step by step and explain it. Normally, I go to the 5 and I borrow from it, and then I put a 9, a 9, and a 10. But what is happening when I subtract and I borrow? I'm going to borrow from the 5, and it does become 4. So I'm borrowing a group of 10 and putting that with the 0. So I put a 1 with the 0, and that's 10. But then I know I have to borrow for the middle 0. So when I borrow from it, then it becomes a 9, and the middle one becomes a 10. Well, I need to borrow from it, so my last 0 becomes a 10. So I cross out my 10, it becomes a 9, and I put a 1 with the last 0, which makes it a 10. So usually what I do is I show you I'm crossing out the 5 and making a 4, and then I put a 9, a 9, and a 10. That's what's happening, and that's where the 9 and 9, 10 are coming from. It's just simply called borrowing through. If you need to show all of the steps, then you will, and I'll try to keep a focus and make sure that I do that with you. All right, so now I can subtract. If I hold up 10 fingers, can I take 9 from it? I sure can. That would be 1. And then 9 minus 6 gives me 3. And then 9 minus 4 gives me 5. And 4 minus 7 is not possible, so I have to borrow from my 2. Right? So when I borrow from my 2, it becomes 1, and the 4 becomes 14. All right, put the 7 down, but 14 minus 7 is 7. And then 1 minus 1 is nothing. So when I subtract 17 and 469 thousandths from the whole number 25, I get an answer of 7 and 531 thousandths. That's your answer. Are we good? Well, let's check it. You do one and come back and check your work with me. All right, so hopefully you thought, because you listened on the last one, I can't just use the 34, right? I have to add a decimal behind it in order to do my first step, which is lining up my decimals. Because yes, indeed, we can subtract whole numbers and decimals. We're simply going to start by lining up our decimals. Once they're lined up, you brought your decimals straight down, you filled in with zeros, and then you borrowed through. So from the 4, it became a 3, and then you had a 10. From the 10, it becomes a 9, and then you have a middle 10. And then from that 10, it becomes a 9 because the last one becomes a 10. And now you should have subtracted. 8 minus 2 is, 10 minus 2 is 8. 9 minus 4 is 5. 9 minus 1 is 8. 3 minus 9 can't be done, so we borrow again. And 3 becomes a 2. The 1 goes in front of the 3 to make 13. And then 13 minus 9, as I already put down, is a 4. And then that leaves me with a 2. Now, some of you forget to check that last number to the left. Make sure that if you had borrowed or whatever, that you check that last one, because some of you just leave it off and then you end up with 4 point. Right, so it's actually 24.858, also known as 24 and 858 thousandths. Right, so hopefully we got this so far. It's not meant to be difficult. It's reviewing things that we've already learned. Now we need to look at multiplying decimals, because there's a large handful of our sixth graders that they don't understand this process, because what they want to do is kind of how we do addition and subtraction. You want to line up your decimals and fill in with a bunch of zeros and try to do the math and then bring your decimal down, and that is all wrong, my friends. All right, so let's take our notes. Our first question: can I multiply decimals? And that answer is yes. What is my first step? I'm going to multiply. That's it. So I'm going to choose to put my first number on top. I can do it the opposite way, because like addition, you can do it the opposite way, but I always suggest that you just start with the first number on top to make sure that your math is set up correctly. So I'm going to multiply, and I'm not going to pay any attention to my decimals at all. I'm going to multiply, and therefore I always start in the bottom right. 7 times 4 is 28. I put down my 8, and I carry my addition of 2. Notice I put an addition of 2 because I had some of you last week and the week before doing some of these problems, and you did something like 7 times 1 is 7 times 2 was 14. Nope, that's not it. So if you put that little addition sign, you take a half of a second of your life to write that little addition sign, then you'll remember that you're multiplying 7 times 1, which is 7, and then adding that 2, which is 9. Now, some of you, we mess this up every time, and we don't know how to fill in and hold place value. I teach it this way. I've been teaching it this way. It's been on several of our videos already. I really need you to take notice of this. And if you mess up multiplying by multiple digits every time, then learn to show these steps. It will take you an extra second of your life, but it will help you get the correct answer. I always underline the next number I'm going to multiply with, because it's the second number. And my second number tells me 2. And when I say those words, tells me 2, I circle all of the digits to the right of it. Well, there's only one. Notice that a circle looks like a number, a digit. Looks like a 0. So I say my second number tells me to bring down 1 0. However many I circled, that's how many zeros I bring down. And now I'm multiplying with what I underlined, so I multiply with the 3. Holding that 0 is required to have a correct math problem. It's required to end up with a correct math answer. So if we can learn to take that extra second of our life to show these steps, then we're ensuring that we have a better chance of getting the right answer. So now we multiply by the 3. And 3 times 4 is 12. So we put down our 2 and carry our addition of 1. 3 times 1, well, that's 3. Plus 1 is 4. And then I have 3 times 0. Well, that's just 0, but I don't need to put it because I don't need it. Now I can add. Notice how everything is lined up nice and neat, and I know exactly where it goes. 8 plus 0 is 8. 9 plus 2 is 11. Carry my addition of 1, because 1 plus 4 is 5. Now, my second step. right? So far, we were just told to multiply. But now when I go back to my questions, my sequences that I'm going to go through and ask with multiplication of decimals, yes, I can multiply them. My first step is I do the multiplication, and now I count my decimal spaces. Notice I'm not saying count decimal points because there's only 2 decimal points. Decimal spaces is how many place value there are behind all of the decimal points in the problem. I always do a diagonal slash when I'm counting them, so I know which ones I've counted and that I count all of them. And as we can see, there are 3 in the top and 1 in the bottom, so there are 4 decimal spaces. I have to then move my decimal from right to left that many times in my answer. So I start behind the 8, and I'm going to move it 4 times. Notice I ran out of digits. What do? Hopefully you thought, well, I just added in a 0. Right? So we end up with 518 10,000ths as my answer. Your 3 steps of multiplying decimals. Can I multiply decimals? Yes, I can multiply decimals. So I'm going to multiply. Then I'm going to count my decimal spaces. Then I'm going to move my decimal in my answer from right to left that many times. It's as easy as that. All right, so let's go through this one, and we're going to see very similar steps. However, we do have an extra number that we're multiplying by. Can we multiply decimals? Yes. So we're going to just simply start by multiplying. So once again, I'm going to put my first number on top and line everything up. Notice the decimals don't matter at this point. I'm simply going to make my 2 rows with my numbers and begin multiplying. So I start with the 2. 2 times 7 is 14. Put down my 4, carry my addition of 1. 6 times 2 is 12, plus 1 is 13. Put down my 3, carry my 1. I do have to go through this next process. 2 times 0 is 0, plus 1 is 1. Now, just like before, I go to my second number. I ignore everything else. I focus in on my second number, which is the 4. I circle how many place value are behind it. There's 1. So my second number tells me to bring down, how many did I circle? 1. So I bring down 1, 0. And now I focus on multiplying with my 4 and I ignore everything else. 4 times 7 is 28. Put down my 8, carry my addition of 2. 4 times 6 is 24 plus 2. That's 26. Put down my 6, carry my addition of 2. And 4 times 0 is 0 plus 2 is 2. Now, this is where it's a little different because now I have a third number, but I still go through the same process. It does take an extra second in your life. However, it does also help you ensure that you're going to set it up correctly to get the right answer. So my third number tells me 2. Notice how many I've circled behind it. 2. So I'm going to bring down 2 zeros. Some of you have missed that concept all along since you started doing this in 4th and 5th grade. I'm explaining it to you. I'm showing you an easy way to show your steps so you know exactly what you're doing and you're able to keep track of everything. Be willing to learn. That way you can be willing to improve. Now I'm going to multiply with my 1. 1 times 7 is 7. 1 times 6 is 6. 1 times 0 is 0. But I don't need to put that. So now I have my columns all lined up, nice and neat, and I begin to add, starting at the right, moving left. 4 plus 0 is 4. 8 plus 3, well, that's 11. So I put down my 1, carry my addition of 1. 7 and 6 is 13, plus 1 is 14, plus 1 is 15. Put down my 5, carry my addition of 1. 6 plus 2 is 8, plus 1, that's 9. All right, I did my multiplication. Am I done? No, because there's a second and third step. My second step, I count my decimal spaces. Notice there are 3 decimal spaces in the top and 2 decimal spaces in the bottom. That's a total of 5 decimal spaces. Therefore, step 3, I have to move my decimal where my answer is from right to left that many times. I counted 5 decimal spaces, so I go behind the 4 and I start moving it, and I only get 4 and I run out of digits. So I simply add a 0 until I don't need to move my decimal anymore. So I end up with 0.09514, which is said 9,514 hundred thousandths. All right, are we good? I hope so. Now let's go to division. So on division, I have to ask my questions once again. I need to fill in my answers on my questions so that I have good notes to look at. Can I divide a decimal? Can I divide a number that's my dividend inside my division box that happens to be a decimal if my outside number is a whole number like the 64? That answer is yes. So once again, we're going to start by raising our decimal. We just did this in our lesson 2.6. Then I'm going to ask, will 64 go into 5, right? I got to divide, and that answer is no. Will 64 go into 52? No. Will 64 go into 524? Yes. How many times? And when I ask you that, some of you are like, I have no idea. I can't do this. And then some of you get really upset. Well, one of the ways you can do it is just take your 64 and do your multiplication problems. You can figure out the 64 times 2 is 128. And you can find out the 64 times 3 is 192. You could do it times 5. You can do it times 7. But when I start saying, well, you need to try and figure out how many times it will go into, then you get mad at me. So reviewing some of the things that our counselors talked about this year and last year is, in your mind, you have different places, and your ability to do math is in your prefrontal cortex, that bright green area, the frontal lobe, that lets you think logically and process through things. But when you're mad at me because I'm asking you to do a lot of math, then that's when your amygdala is taking over, right? Your amygdala, once again, is involved in your extreme emotions when you get angry, right? And your amygdala, then will not let you use your prefrontal cortex. It keeps you from being able to process and think, right? So I'm going to remind you of something. You have a calculator. And some of you are like, oh, you begin to calm down. You're like, I might have forgotten how easy you try to make math, Mr. Barker. Well, then just learn to relax and we can do our math together, okay? So let's divide. If I take 524 and I type it into my calculator and I divide by what's on the outside, my divisor, 64, then I find out that that is 8 and stuff. And once again, I don't care about the stuff. I need to know that it will go in 8 times. Now, notice I used my 3 digits, my first 3 digits, the 5, 2, and 4. And since I used the third digit, my 8 has to go above the third digit. And I'm emphasizing this because some of you do this wrong every time. You just want to put it in front of the decimal. No, that's not it. Right? If I had only used the 5, it would have gone above the 5. If I had used the 52, it would have gone above the 2. But I have to use the 524, so the 8 has to go above the 4. And then I use my handy dandy calculator again to continue on. Well, I know I'm doing 8, my answer, my quotient, times 64. And what do I get? Handy dandy calculator tells me that's 512. And now I can subtract. 4 minus 2 is 2, and 2 minus 1 is 1. So now I bring down my 8. Will 64 go into 128? Hey, we just worked that one, right, before we thought about our calculator, and I could see that 64 will go into 128 2 times. Notice it goes right above the 8. 2 times 64 is 128, and I don't have a remainder, right? So dividing a decimal by a whole number is not a problem. We simply divide after we raise our decimal. That's it. And we continue to divide if we have any remainders. On this one, it's just simply 82 hundredths. So what about this one? This is why we ask the same question as we begin these problems every single time. Can I divide by a decimal? Can my divisor, can my outside number be a decimal? And that answer is no. It is impossible. You cannot do it no matter what, no how, no way, nuh-uh. Right? We reviewed this last week, and once again, we talked about how we have to do the over, up process to find the correct answer. So once again, my first number has to go inside my division box. It's what I have, right? It's my dividend. And then I'm going to divide by the second number. That's my divisor. That's the size groups I'm going to put it into. And then I tell myself, no, I cannot divide by a decimal. So I have to do my over, up. I have to move it on the outside however many times from left to right to make it a whole number. Well, in this case, I have to move it twice. Therefore, I have to move it on the inside the same number of times. Notice there's already a decimal. Just a reminder, if there wasn't already a decimal, you would put it at the end of the number, like in the example in the box that we went through last week, right? We would add it to the end of the 114. There is a decimal point already inside the box, so we're just simply going to move it 2 times. And then what are we going to do? We're going to raise it straight up. So over, up tells me to go straight up. And then I start asking my division questions. Will 12 go into 0? No. Well, now I got 2 zeros. Will 12 go into 2 zeros? No. How about 6? Will 12 go into 6? No. But notice it's behind the decimal now. So I have to say 12 will go into 6 how many times? It goes in 0 times. I have to hold that place value. Then I'm going to add a 0 and ask, will 12 go into 60? It will. And if I use my handy dandy calculator, 60 divided by 12 is 5. Because 5 times 12 is 60, I have a 0 remainder. So our final answer is 5 hundredths. But dividing by a decimal, as we talked in lesson 2.6, is not possible. So we have to do our OOU. So how about this one? Right? So one of the things we have to do is be willing to persevere, and sometimes we end up with really long numbers. Once again, which one goes inside the division box? The first one. So hopefully you have 60.927 inside your division box. Therefore, your second one, that is your divisor. It's on the outside. And then I ask myself, can I divide by a decimal? And I say no. So I have to OOU it. I have to move it on the outside however many times from left to right to make it a whole number. In this one, I have to move it 3 times. Therefore, I owe it again, but I'm doing it on the inside this time. I moved it 3 on the outside. I have to move it 3 on the inside. Then I move it straight up. And then I'm just dividing by 12. I get my handy dandy calculator and I start my dividing. Will 12 go into 6? No. Will 12 go into 60? Yes. How many times? Well, if you don't know and you don't remember from the previous question, then you type in, once again, what's inside the box. 60 divided by the 12. And 60 divided by 12 is an even 5. So 5 times 12 is 60, so I have a 0 remainder. I bring down my 9. Will 9 go into 12? No. But once again, if I bring something down, I have to bring something up. So I ask, how many times will 12 go into 9? And that is a 0. I bring down my 2. Will 12 go into 92? Yes. How many times? I don't know. So I get my handy dandy calculator. 92 divided by 12 equals, I get 7 and stuff. I keep my 7, I get rid of the stuff, and I show then that 7 times 12, type it into your calculator, you get 84. Now we have to subtract. So I borrow from my 9 because I can't hold up 2 fingers and take 4 from it. My 9 becomes an 8, and my 2 becomes a 12. And then I hold up my 12 fingers and I think how weird it is that I have 12 fingers, and I subtract 4 and I get 8. I bring down my 7. Will 12 go into 87? It will, 7 times. Still is going to be 7 times 12 is 84. And now I have a 3. Notice we have that decimal there, right? So we have to add a 0 and bring it down. And now 12 will go into 30 how many times? Well, that's 2 because 2 times 12 is 24. And now I have a remainder of 6. Can I just throw my 6 up there at the end of my decimal? Nope. I keep adding zeros and bringing them down until I don't have a remainder. Will 12 go into 60? Yes, it goes in 5 times, which is what we started with, because 5 times 12 is 60. So my final answer is 5,077 and 2,500, right? Several steps, persevere, doing the math, making sure we're correct. You try this one. Let's see how you do. All right, so hopefully you set it up with the first number inside your box, 2.943, so 2 and 943 thousandths, divided by the 27 hundredths on the outside. That's my divisor. And you ask yourself, can I divide by a decimal? That answer is no. So you knew you had to OOU before you could divide. You had to move it 2 times on the outside, therefore you had to move it 2 times on the inside, and then you raised it straight up so you don't forget it in your answer. You asked yourself, will 27 go into 2? No, but it will go into 29 one time because 1 times 27 is 27. I get a remainder of 2. So I bring down my 4. And then hopefully you said, well, 27 won't go into 24. However, I brought something down, so I have to put something up. So 27 will go into 24 0 times. Then you brought down your 3. And you typed into your handy dandy calculator 243 divided by 27, and you get 9, which is 243. So hopefully you got 10 and 9/10 as your answer. How'd you do? All right, so in your packet, your reference packet that I know you have in here in your math folder, because I asked you to, do me a favor and find this page, and then notice right in the center of the page, there is this image, and you should highlight around it, right? So they're showing you the steps and with very few words, but this basically consolidates all the notes that we just went through. I find that students often, when they look at their notes, they understand it better than what these images are showing you. There's nothing wrong with being able to look at this also to remember how to do your division, multiplication, addition, and subtraction using decimals. So that is there for you for tests, homework, assignments, anything you need it for. So our next class, all we're doing today is taking notes, is to do the assignment and ask questions if we have them.